All right, it's 11:01. Let's go ahead and get started. So good morning and welcome to the latest installment of Mazzetti's Bending the Climate Curve lecture series. I'm Christina Vernon Sanborn, Sustainability Practice Leader here at Mazzetti, where bending the climate curve is our mission. Electrification is a hot buzzword in designing and managing healthcare energy systems these days. However, why is electrification suddenly gaining momentum, particularly related to central utility plants? How is this both a resilience and decarbonization strategy? And how do you pull it off in a responsible and effective manner? Today, we'll explore these questions and more. Before we get started, a bit of housekeeping. Today's event qualifies for one AIA CEU. If you did not provide your AIA number when registering, please send it to info@mazzetti.com and we'll take care of it. Today's session will address these four learning objectives. We will hold questions until after today's speakers have made their presentations, but you can submit your questions at any time via the Q&A function of the webinar. We encourage you to enter them the minute you think of a question. Feel free to add them into the Q&A. Today's session is being recorded. Now I'll introduce the moderator of today's panel, Jamie Kwok, who will introduce the rest of our panelists in turn. Jamie is a senior project manager and associate principal at Mazzetti. He's been an equipment vendor, consultant, commissioning authority, contractor, and designer on projects that range from aviation to higher ed, to sports, to healthcare, to science and technology projects. Jamie's also written and delivered graduate courses at Vanderbilt and Lipscomb universities on design, construction, and operation of facilities in renewable energy. He currently serves on California State's East Bay's Big Data Advisory Board. Jamie, take it away.
Thank you so much for that great introduction. Good morning and welcome to all of you joining us as we engage in this vital conversation. Today, we are fortunate to have a group of distinguished panelists who will share lessons and insights from their journeys on the path to electrifying central utility plants on their medical campuses. Each panelist here today brings a great deal of experience and knowledge, and I'm excited to get started. It's important to acknowledge we are all on a journey towards electrification, one that many of you are on as well. You might just be starting out and hope to join this presentation today in order to get a head start on the path you are on. The point being, electrification and more broadly decarbonization are still in the early stages of market adaptation and even some cases acceptance as a strategy to tackle an uncertain energy future, climate change, and the desire for resiliency in our central plant systems. While we may all be at different stages along the way, the important thing is that we are on the path that seeks to address these issues at scale. Let's consider the role of buildings and central plants. Buildings and central plants, in the case of our topic today, represent a large opportunity to reduce or mitigate carbon emissions associated with the built environment. Market-wide, one of the biggest users of electricity, one of the largest emitters of carbon, and therefore one of the chief contributors to climate change. But electrification is only one piece in a much larger and more complex puzzle, and is only one critical component of a broader strategy to decarbonize the entire economy. One aspect challenges us to rethink how we generate, transmit, distribute, and store electricity. Every day we're reading about improvements to distributed generation products and systems, more recently developments in on-site storage systems, now both considered part of many central utility plants. Changes to personal and commercial transportation are also evolving in response to and support of these goals. And what we find is that all these things, including many more related to effectiveness and efficiency of processes and building systems, must be done, all of it, to ensure our success. We can't afford to leave any stone or opportunity unturned. However, this journey is not without its challenges or struggles. In the case of our buildings, equipment, and systems, and for today's central plant equipment and systems, we are now asking new questions as we develop our designs. We're evaluating new system types, including heat recovery chillers and air source heat pumps, while even looking to capture waste heat in buildings through heat exchangers that we had not done before. And let's not forget, also becoming more common is the addition of sometimes massive thermal energy storage tanks on the range of millions of gallons. These new systems might be the way of the future, but they are taking up more space and require new ways of thinking about plant operations. And as these systems might not have been electrified before, they certainly impact the size of a building's electrical service and also the size and approach for emergency systems, reliability being of the utmost importance at acute care health facilities. These are the issues we are here to discuss today. Please engage with the panelists and share your questions with us while we're talking, and we'll do our best to try and include those in our conversation. So let's get started. First, we'll have Russell Smith. Russell is a senior superintendent of plant operations and maintenance at UC Davis Medical Center in Sacramento, California, overseeing the central plant for the past 6 years. With 25 years of power generation experience, Russell previously worked for a large manufacturing and servicing company specializing in gas turbines, steam turbines, and generator equipment. His extensive expertise ensures efficient and reliable operations at one of California's leading healthcare institutions. Russell?
Good morning. As previously stated, my name is Russell Smith, and I manage the central plant here at the UC Davis Health Sacramento campus. The Sacramento campus, quick overview, has clinical buildings, research buildings, and educational buildings. The largest complex on the site is the medical center. The medical center is the only level 1 trauma center in inland Northern California. The size of the campus is roughly 4 million square feet of usable space and over 50 buildings on 145 acres. There's roughly 14,000 employees that work at the campus, and we serve approximately 3,000 patients every day. 3 billion yearly operating budget, and we spend about 10 to 15 million per year in utility costs. UC Davis Health is taking a phased approach to electrification. This is being driven by growth at campus and UC policy. The first phase is pretty standard, straightforward. We have a same-day surgery center that's being built. It's actually almost complete, set to open in 2025. And so we had new underground utilities that had to be ran to that new facility, as well as we had to add some additional chiller capacity in the plant. Phase 2 is broken into several sections. The first section is more underground infrastructure for the new California Tower, which is a 14-story hospital bed tower. And a central plant annex building that will house new electrical switchgear and new emergency diesel generators. After that, we go into the phase of a new utility connection. With the added electrical loads that the campus will have, we need a new 40 MVA connection to our local utility. Additionally, there's one more step before we can make a big shift towards electrification, and that's reducing our current heating hot water temperature so that it'll work with new electrification technologies. Phase 3 is that big shift. That's when we're going to install our TS tanks and also our heat recovery chillers. And then phase 4 is the ultimate fully electric central plant where we'll use air side heat pumps to generate all the heating that's necessary for the campus. So a number of challenges with the electrification journey. The first being reliability. Our existing central plant and energy supply for the medical center is actually provided by a cogeneration unit. Very efficient system that we have on site, and also very reliable. We have the capability of being completely disconnected from the grid and fully powering and supporting the Sacramento campus. No interruption to any services for any patient care, and being completely isolated. So with wildfires, extreme heat, flooding, those types of things, the reliability, resiliency piece of the cogen is hard to find. We have looked at finding a carbon-free that has the same capabilities, and to date we have not found a technology that completely meets what the cogen can provide. Cost is another factor. There will be most likely a 3 to 4 time utility cost increase with moving away from natural gas and being purely electric. And then first time costs, of course, we're looking to be in the billions of dollars to get to the end of phase 4. Space is another thing. As previous map showed, not much room on campus. So basically we have to remove buildings or demolish buildings in order to build the infrastructure needed for the electrification codes. Being a hospital, anything that is powered by electricity that is going to be critical to patient care has to be on emergency power. And so the addition of more emergency diesel generators is needed that we can maintain our accreditation. We also have backup heating that's needed. We can't depend on just a single source of energy for heating. We have to have a second energy source for heating. Electrical feed size. So we're working on getting the first 40 MVA connection in order to get some added resiliency and redundancy to the utility. We have to upsize our existing 25 MVA to 40 MVA. And then one of the final challenges is the heating hot water. This is throughout all the existing buildings, piping sizes, piping that's not rated for the lower temperatures, as well as heating coils and those types of things that all have to be studied and then retrofitted to work with the lower temperature. And I think that's what I got. I think you're on mute, Jamie.
Thank you, Russell. Appreciate that. One quick question that came up and I think is relevant. I'll go ahead and ask, your future plan for your project includes a 5 million and 3 million gallon chilled water and hot water thermal energy storage tank. Someone's mentioning that they take up a lot of space. I'm not sure. The second part of the question asks if there are technologies to reduce their overall footprint. And I'm not sure that there is a technology that exists to address that. And thermal energy storage tanks are just going to be big if you want a large enough battery in order to be effective in serving your facility. Let's move on next to Anna Levitt. Anna is a licensed mechanical engineer in California with more than 17 years of experience in energy engineering and program management, 15 of those spent at the University of California. She manages the energy, utilities, and infrastructure team, as well as leasehold operations at UC San Francisco Health. Previously, she was energy manager at UC San Diego Medical Center and campus. At UCSF Health, she oversees the facility's decarbonization, energy and water efficiency, HVAC controls, and infrastructure renewal programs. In her work at UC San Diego, she managed the campus's $95 million energy efficiency program, which included major research laboratory, building HVAC retrofits, cogeneration plant heat recovery, lighting retrofits, and retro commissioning. Anna holds a degree in mechanical engineering from Smith College and a Master of Engineering from San Diego State University. When she's not managing energy, she's playing old-time American fiddle or spending quality time with her wife and 2 young kids. Anna?
Thanks, Jamie, and good morning, everybody. Nice to be here. So UC San Francisco Health, we are one of several of the University of California systems, just like UC Davis Health. We are in the Bay Area. We have 5 hospitals in the city of San Francisco, 1 in Oakland, the Benioff Children's Hospital in Oakland, including 2 children's hospitals amidst that portfolio. And those hospitals range in age from the 1940s to the 2015. So a wide range of ages in our portfolio of buildings. In addition, we have outpatient clinics, including several surgery centers throughout the Bay Area, many of them owned, some of them leased. And so a lot to work with and operate even as we work towards this goal of decarbonization. In addition, we have some major projects in the works. So just in the last month, we opened a brand new surgery center at our Mission Bay campus called the Bayfront Medical Building. It's actually a standalone building that's all electric and carbon free. It actually doesn't even have a natural gas line run to it at all. And it has opened successfully with some careful commissioning and a wise design. And also in construction, we have a new hospital in the Parnassus Heights neighborhood, Helen Diller Hospital, that is scheduled to open in 2030. That's a project that Mazzetti is working on. And then in addition, we have the Peninsula Outpatient Center down in Burlingame, which is a standalone surgery center, and Benioff Children's Hospital, Oakland. All of these will be all electric and carbon-free, with the exception of the brand new hospital in Parnassus, which will be about 90% electric and carbon-free. So we're still very, very proud of that achievement that we're working towards. As a whole, as the UC system and as UC San Francisco as a whole, we have some pretty significant goals for decarbonization in the future. We are shooting towards being fossil fuel free, and that's defined as 90% below our 2019 baseline by the year 2045 as an institution. For those who know your scopes, that includes scopes 1, 2, and 3, but today we're mostly focused on 1 and 2. So what's actually being emitted by our energy systems and as a result of our energy systems. And then we're also looking to establish interim goals in the years 2030, 2035, and 2040 to really try to reduce our fossil fuel, our greenhouse gas emissions as aggressively as we can, as soon as we can. We've just completed a major study of all of UCSF to figure out what would it really take to fully decarbonize not only our new construction, but our existing. And it'll be hard, but it can be done with existing technologies today. So we're laying out a plan that is similar to what Russell described at UC Davis Health, that is reliant on heat recovery chillers, thermal energy storage, and to the point of space, talk about a constrained environment. In the city of San Francisco, our campuses are extremely constrained. So that'll be an interesting challenge to figure out. Just to quickly address that question, I think the philosophy for that for us is some is better than none, and distributed may be required. We're not going to find a place to put a 5 million gallon tank, but maybe we can put a number of tanks in different locations and tie them together. Our solutions will also be dependent on air source heat pumps and possibly geothermal on one of the campuses. We're continuing to explore that. Major challenges for us are we're scattered to 6 different campuses. And so that's basically 6 independent projects, all of which require management and funding, et cetera. Costs. I have a very similar list to Russell's. It's going to be very expensive. We're looking in the billions to be able to achieve such a thing. But our leadership is serious about really trying to make this happen. Operating costs will go up for the most part. One of our campuses does have a natural gas-fired cogeneration plant that has been a money saver for decades. And electricity in California is not cheap. Of course, this doesn't take into account the social cost of carbon. And I'm grateful to be at an institution that recognizes that that's a real consideration, and in line with our charge to do no harm. We're looking to minimize that. Resilience is key. So part of the plan will be to add new electric feeds from the grid and trying for that to use different utility substations than our existing feeds. Getting to low temperature heating hot water. Some of our buildings, it may not be too challenging, and others have steam distribution, and it would be an enormous hill to climb, but one that can be done over time. Of course, the challenge of working in operating facilities with critical needs. And the last one, which I already mentioned, space. It's one of our biggest challenges in San Francisco.
Yeah, thank you, Annette. I think, yeah, you certainly, whereas many campuses don't have that problem, are restrained with real estate and where you can put things, or just another added wrinkle to the complexity of your strategy at UCSF. Shortly, we're going to have some question and answers to get the team talking about some more anecdotes in their experience. But first, we're going to hear from Brian Entman. Brian is a project executive and director of technical services for Rudolph and Sletten. He started his career in Chicago designing industrial refrigeration systems for dual temp companies. In his 18 years with Rudolph and Sletten, he has tackled projects in nearly every market sector, including healthcare, life sciences, pharmaceuticals, corporate campuses, and data centers. Throughout his career, he served in roles as a designer, builder, and commissioning agent. As Director of Technical Services, he oversees all of Rudolph and Sletten's mechanical, electrical, and plumbing aspects of their projects. A graduate of the University of Illinois at Urbana-Champaign with a degree in mechanical engineering, Brian is also a licensed mechanical engineer and certified energy manager. Brian?
Thank you, Jamie. Good morning, everyone. From the contractor's perspective, we are seeing things that are very similar. Hold on, I have a squeaking dog toy in the background. Hold on 1 second. That was a prop specifically for this. It has to do with this presentation, I promise. From the contractor's point of view and our perspective, what we're seeing a lot of is similar to the things that that Russell and Anna were talking about from a client perspective, the reasons that they're going with electrification, not necessarily code driven, but they do have a vested interest in eliminating the gas infrastructure from their campuses or from their buildings, whether it's specifically for their own corporate or campus goals, or if it has to do with just location or their facility in general and what they can achieve. A lot of it also has to do with the elimination of distributed steam systems. We are seeing a lot of campuses starting to ditch mass distribution. It's very wasteful. It's tough to maintain. It does, it's inefficient. So going with a lot more localized point of use steam and heating options and alternatives has also been something that we are seeing in the market. And then there's also the secondary benefit of electrification, and that is actually on the water savings side. We had a client whose actually goal for their campus was to be net zero on their water consumption, utilize heat recovery chillers as their means of achieving that. And then the benefit was the electrification of their campus and not needing natural gas for any of their heating. So some of those secondary benefits also come into play that sometimes people don't realize when moving towards electrification. Some of the unique features for those that aren't familiar with what to expect, and I think Russell touched on this a little bit, and Jamie as well. It's larger electrical equipment. You have larger loads. So the equipment, the rooms, the programming space that's necessary. What we were typically seeing in California before, like for a hospital, you might expect 6 to 8 watts per square foot of emergency power requirement. Now with electrification, it's going to be closer to 12 to 18, even greater, depending on what you want on that emergency system. And a lot of that is driven by the need for heating to be on emergency power. But again, those emergency power rooms, that emergency distribution gear, generators, all of that equipment is growing in size as a result of electrification. So it is something that you have to be mindful, or we have to be mindful of. The same thing is, how much outdoor space or indoor space do you have for the equipment? In California, what we are seeing is more outdoor, so air source heat pumps, air-cooled chillers, and then air source sink heat recovery chillers that can serve dual purpose to handle both the peak design seasons and then also your shoulder seasons, to where if you don't have enough cooling or heating to satisfy the other end of the spectrum, you still have that air source sink option. But all of these things require larger mechanical yards. If you are going outside, or larger roof space, or wherever you're planning to put these, that has to be part of the design decision in the conversation. As I mentioned before, we are seeing a lot more localized utility services, the elimination of mass steam distribution. So for sterile process, you'll have localized point of use steam distribution. For humidification, you'll be more localized and eliminate the need for those large steam systems that not only producing steam and waste heat, they're serving heating demand as well, which was a big process and was very costly for maintenance purposes. As I mentioned, a lot of these systems are becoming modular. So we aren't seeing as many larger centrifugal heat recovery chillers. We are seeing more of the smaller modular scroll type systems, where it's a lot of different chillers in one package. The challenge there is how many modules and how much can you achieve from one particular unit. And I think Jamie mentioned these things are getting fairly sizable. And even at 300 tons, a modular heat recovery chiller at 300 tons is very long and takes up a lot of space in your mechanical yard. So again, the modular aspect is there, but the spacing isn't, the footprints are still something that need to be negotiated. And then just the unique feature from an air source heat pump standpoint, for those that aren't familiar with it, they're reverse cooling coils. So they are going to condense. There's going to be a lot of water pouring off of these things at different times of the year. So there are opportunities for water reclamation. So again, that added secondary benefit of using some of this equipment, especially in California, where water is a definite scarce resource in a lot of places, using some of these electrification alternate benefits go a long way. Okay. And then lastly, the biggest challenge for us actually is on the procurement and the startup side on both ends of the spectrum. One of the problems is we see demand exceeding supply. So as this, push to electrify becomes more and more prominent, we're going to start seeing a lot longer lead times for equipment. But we also are starting to see even now quality control possibly being sacrificed in the factory. There's such a rush to market with the equipment. It does seem like some of that testing and some of that attention to detail on the manufacturing side is slipping. Again, I think manufacturers understanding the size of the equipment and the footprint things take up. They're also trying too hard to reduce that equipment footprint and trying to cram 10 pounds of stuff in a 5-pound bag, which makes things challenging from a startup and an overall reliability standpoint for the equipment. And then I think they're making things a little bit more difficult than necessary. Everybody's trying to achieve ultimate efficiency, perfection in performance. And at the end of the day, these things they're chillers and they're heaters, right? And we just need to simplify the process and not get too wacky with all the different options and all the different optimization methods that we're trying here. The persistent equipment failures are also a challenge, in large part because of the things I mentioned on the left there, and that we see a lot of coil failures, which is something that we didn't have to address, several years ago with standard chilled water equipment or with boilers. See a lot of fan failures on the condenser side, and then also controller failures. So these things are tricky to start up, and there have been some challenges, and we do have equipment in service now that 2 years later, we still haven't necessarily gotten out of a warranty phase because we have continued to replace components, the same component, sometimes over and over again. So the definitely challenges, but at the end of the day, I think the benefits definitely outweigh some of these costs here. Jamie?
Yeah, great, Brian. Thank you. And certainly appreciate the vendor and manufacturer perspectives as well, because they are a big piece of that puzzle. And there's still a long way to go to improve and provide the types of equipment and systems that we're seeking to fully achieve our goals. So thank you, Anna, Russell, and Brian. Those were great updates to what's happening on your campuses and what you're working on. We've got some questions coming in. Please continue to send your questions in. We'll try to get all of them answered. We have some that we've talked about ourselves ahead of time. We'll try to get to some of those as well. But first, Russell, I wanted to come back to you. Your slide mentioned increasing your primary service from, I think, 25 MVA to 40, effectively doubling the service that you're going to have at the campus. You shared a good story about the challenges of that and even the pathway of getting that service to the facility. I was hoping maybe you could share some of that with everyone again this morning.
Yeah, so we're at the substation level, our connection into SMUD, and we have our existing 25 MVA feed to SMUD, our local utility, and then we have our gas turbines. So we basically have two primary sources of electricity. The size of the campus is basically going to be larger than both, right? I think we're projecting with the tower being online, being somewhere in the 31, 32 megawatt range on campus. Our cogen unit maxes out at about 26, 27 megawatts. And then of course our 25 MVA feed wouldn't be enough for that either. And so trying to coordinate up, basically on an operating running hospital, trying to run a new line into the facility. This is the station is across the freeway, so we have to get over the freeway or under the freeway. We got to go through a neighborhood, and then we have to get that into an existing plant, into an operating plant. There's a lot of coordination, and there's a lot of cost. I think the cost of the standalone 40 MVA feed is somewhere in the neighborhood of 60 to 70 million. The cost to upgrade our other feed is somewhere in the neighborhood of 25 to 30 million. So not cheap things, and lots of coordination with the local utility. There's been some surprises in dealing with the local utility and what we had envisioned originally with the plan versus what they told us after we got into it. So it's a long-term process. Really, we're looking at probably 8 years to get that feed. So anybody looking to enlarge their feed have to start early, have to start those conversations early, regular meetings, and understanding the challenges that you're gonna have, especially if you're somewhat landlocked in a neighborhood or a city.
Yeah, I mean, over the river and through the woods to get the electricity you need. Russell, you and Anna both at UC Davis and UCSF have cogen facilities. People seem to be a little interested in that in a couple of ways. One being your interaction with and how the utility is responding to your goals of disconnecting from gas in the future. I was hoping maybe Anna, you could start. Both of you could talk about the situation of, cogen being a reliable source for all these years for what you've needed, but now planning to disconnect it and move on and do something very different in the future.
Yeah, so I guess a couple questions in there. One is, how is the utility responding? And then the second is sort of, what about the reliability and resiliency impact of disconnecting? So on the first front, for us, the utility is PG&E. They provide both the gas and the electricity. They have not expressed any concerns to us about, the change in gas consumption. I think in the grand scheme, it's not a significant issue for them. On the electricity side, we have engaged them in conversation. And we actually have, just generally in the city of San Francisco, the ability to use PG&E or San Francisco Public Utilities Commission for electricity supply. So we're exploring both of those options. Certainly, it requires a significant amount of upfront planning and discussion. They have basically let us know that they can provide the capacity we're going to need, period. There may be challenges along the way, but in terms of the numbers that we've showed them for each of our individual sites, they have been able to indicate where they will have to do upgrades to the system in order to accommodate and where they won't. But it's going to be costly. So I think it's doable, but it's going to be a significant challenge for sure. And then the second question about the sort of resiliency impact of disconnecting cogen. Absolutely. The cogen plant has been a major resource for us since it was started. It's provided backup power in the grid outages many times over. I guess a couple of things. One is we just have to design for it. So grid outages are going to happen for sure. And adding redundant utility feeds is definitely going to minimize and help us with our resiliency in those moments, but they will still happen. So making sure that we have that backup capacity. For us, we're exploring not only having sufficient diesel generator backup, but also having natural gas boilers. So for Russell mentioned, we have to have a backup for our heating systems for our hospitals in California. It doesn't have to be a diesel generator. It could be another source of heating. So a natural gas boiler is also a viable alternative. And that allows us to make those emergency generators not as big by serving it through another means. So just really carefully thinking through those backup plans, making sure we have a plan A, plan B, plan C.
Yeah. Russell?
Yeah, so I think a unique situation, it's considered as special facilities for us, so that the line that we have to the substation just only feeds the medical center here in Sacramento. So our existing line is set up that way, where we basically have paid SMUD to build us a specific 21 kV line and have our own. It's still a SMUD transformer, but it's basically only serves us from their substation. And so as long as the substation has the capacity, it's not an issue. And yeah, those were planning discussions that took place over the past several years. We're hooked to Mid-City for our current one. We wanted to be on a separate substation for that reliability piece, and so we're hooking up to East City, which actually is a newer substation for our second feed. And then those are dedicated to our campus, those two feeds. I think the transmission size and the infrastructure piece, since we're paying for most of it, that's not so much of a concern with SMUD. The part that is concerning for them is when we are actually going to shut the cogen down. They do want to know when we are going to shut it down ahead of time, so they can make sure that they have those resources available for us. And so, currently, in the current situation, as they're trying to build out to their carbon-free future, especially in the summertime, we're heavily relied upon to cover our own load and at times export to the grid when there are severe limitations. So it somewhat appears to be a little bit of a fragile state. I know everyone's trying to get to that future state. SMUD's bringing on storage solutions, more wind, more solar. It's just when the sun goes down in California, that's when things get tough, when it's 100+ degree days in Sacramento.
Yeah, certainly it does get a little bit hotter in Sacramento than San Francisco, to be sure. One of the things we touched on was, the types of services we're trying to electrify. And, Brian was talking about the vendor community trying to hustle up different and new types of equipment for us to use. One thing that is absent in the market is electrified steam generation at scale, or at least there's some in the early stages. And then thinking again, Anna, you talked about your emergency strategies. How are some of those limitations of what the vendor community can provide affecting the interim planning that we're doing, knowing that maybe 10 or 15 years from now, some of those solutions will be better or will arrive. But right now we're having to deal with what vendors can provide us. How does steam generation and the broader preparedness for emergency, how is that affected by just what's available in the marketplace and the types of designs we're constrained to with that? Anyone? Maybe Anna, you start.
Sure. I mean, I guess the good news for us is, for sure, that's a significant concern. We are not really interested in being on the bleeding edge of technology as we move forward with this, because we really need it to work. We've had challenges. I see a lot of discussion in the chat box about challenges with chillers and things in recent years, and we have had those, even with conventional chillers. And so, yeah, we're not eager to be on the bleeding edge of major technologies changes. When it comes to steam generation, I mean, our goal is to reduce our dependence on steam as much as we possibly can, so that equipment doesn't have to be extremely high pressure and extremely high capacity. So, we're installing electric sterilizers, which is one of our big steam loads, is sterilization in hospitals. That's just point of use, and trying to do as much point of use as we can. And in terms of if we do move forward and need a central steam distribution system, it'll be years down the line, and we'll see what's out there at that point.
Yeah, thank you. Brian, Russell, anything to add to that?
Yeah, no, I know and I know Mazzetti's working on it, is the California tower is all point of use steam, so all the sterilizers that's going into that building. We have our existing infrastructure, and it's primarily steam supplied from the cogen with natural gas boilers as a backup. In addition, those natural gas boilers can actually fire on diesel fuel, so in some ways we have three ways of getting steam to the hospital for that stuff. We also use it for humidification in the rooms and the kitchens and those types of things. So that's all infrastructure that has to be updated, but definitely going forward, everything's looking at point of use for steam so that we can get away from as much of a centralized steam source as possible, because that is one thing with electrification. Purely electrode boiler is not considered efficient, and so that's kind of the one challenge with hospitals and figuring out how we're gonna do that, especially when you have a existing infrastructure.
Yeah.
And if I could add, Jamie, just Russell kind of hit the nail on the head. It's the existing infrastructure is already there for a lot of these facilities, and they're kind of married to it, and breaking that relationship with mass distribution steam, especially after all the money that's been put into improving the infrastructure or adding additional infrastructure over the years up until this point, then telling somebody that they all of a sudden have to build a new building with an electric boiler in it or other options for steam. That's a tough pill to swallow. Sometimes, especially a lot of facilities don't want to have, oh, I have all my equipment in a central utility plant, but I got this new building with, this electric equipment, several hundred yards away that has to be serviced separately, that I got to send guys out there in the cart and do all these other things. You start breaking up the centralization of the plant sometimes by doing that. And that is a difficult decision. And often I think, a decision that's frowned upon by a lot of the facilities folks too. So it's tough when you have an existing, steam distribution on campus to sort of break that trend.
Yeah, excellent points. One other thing that we've talked about in leading up to this presentation today was on-site generation, storage. We had a conversation of cogen versus fuel cells briefly. I wondered if any of you would like to speak about your university or projects you're working on and how you're integrating not only renewable energy generation on site, but also potentially storage as microgrids are becoming more and more a part of central utility plants and those systems that we consider as, just a part of those. We maybe didn't think of it that way before, but now microgrids, on-site generation and storage is definitely a part of the types of systems you see in central plants now.
So, I can kind of go a little bit, we have looked at site storage solutions, kind of alluded a little bit to technology. Batteries is obviously a first thing that we typically jump to. And unfortunately, technology is not quite there. We have a fairly large summer peak at about 17 megawatts. And like I said, that's going to go up to 31 megawatts. Just the size and what you get is a challenge with the battery front. So really need that technology to come along and shrink the size of those batteries to really make that something viable and cost effective. We've looked at flywheels. Again, space concerns, very, very challenging to get a flywheel of sufficient size that could provide a benefit to us at the campus. And so fuel cells, we had a discussion about fuel cells. The issue is with fuel cells burn natural gas as well. And so we still have a carbon issue when we use fuel cells, but potentially if there's a hydrogen infrastructure that comes into place or those types of things, fuel cells could become more viable. Even for emergency backup generators, we were looking at trying to do batteries, but current accreditation codes don't really allow for it. So I think that would be a more low-hanging fruit opportunity, is that if we accreditation and everybody could get on board and figure out a way to, because burning diesel is a lot dirtier than burning natural gas. So that would be a potential benefit, that we would no longer have to have all these diesel generators everywhere, and we could have battery storage to provide that backup power.
Yeah, excellent.
Yeah, and for UCSF, definitely batteries are a consideration. Space, as Russell indicated, is the challenge. Really, energy density of all these technologies is a real challenge. In terms of other on-site generation, we will absolutely cover every remaining spot we can with solar, but in the grand scheme, it's just not significant enough. So we'll put together the technologies that we can, but ultimately we're going to be dependent on sort of additional technologies until further notice.
Yeah, thank you. So renewable energy is always one of the first things that comes up, right? But the ability to apply it at a scale such as a medical campus or a central utility plant can be a challenge. Though I think what we're seeing is that campuses are taking this on and doing it in a piecewise or stepwise kind of approach to capture, a building at a time or some portion of the load at the time. But it sounds like from both of you that actually being able to fully offset with on-site renewable generation would require significant advances, not only in the, say, solar panels conversion and the ability of batteries to store at a much higher density than what we're seeing today. So again, we're waiting, just like with HVAC equipment, for a lot of the vendor community to continue to develop and provide products and systems to the market that would make an even larger impact than the types of things that we're seeing in designs that we're implementing today.
Jamie, I'll just add one additional item just to make sure folks are aware, because it can be a game changer, that the Inflation Reduction Act significantly supports those technologies. So that's a good reason to investigate them seriously.
Certainly. Thank you for bringing that up. I'm surprised we went this long without mention of that. But speaking of timelines, one of the questions from the audience is, what is your timeline? What does it look like to fully electrify, a campus, or in this case, a central utility plant? Russell, you kind of touched on the length of time it takes to do discrete tasks, but what is the long-term outlook of getting to some end goal and looking back on what we've done?
Yeah, we're saying 2040 plus. The policy is 2045. And so that is what we're looking at. So it's not completely planned out. I say really the big thing is not completely funded at this point. So but we're funding as we go and trying to tackle as many pieces as we can. I think Anna kind of alluded to something like taking these smaller chunks, these huge tanks that we have to install, these TES tanks, is 5 million gallon and 3 million gallon. Can we do one first before we do the other one? We've talked about maybe we can put the heat recovery chillers in and they won't be as beneficial, but could we start that path in kind of smaller chunks to help with the funding situation as we move forward? And then I think that final airside heat pump is still technically there's a solution, but that is a huge solution. I mean, it's going to take a lot of space for that as well. And so hopefully as we get closer to 2040, there's something else out there.
Yeah, right.
And for UCSF, we don't know our timeline for sure. We know that we definitely plan to meet it by 2045, but as a wise mentor has pointed out to me, the more we can do sooner, the more impact it'll make to the earth and the rest of us. So, 60% by 2035 is a lot more important than 90% by 2045. And so we're looking at making significant progress by 2035, and then tackling most of it by 2040, with the remaining 5 years to do the rest. But again, it's entirely dependent on financing and our ability to get it all funded.
Yeah, thank you. Brian, turning towards you for a moment here, I've got a question from the audience. Statement is, all electric designs require a significant amount of coordination. I think we all agree with that. From your contractor perspective, and also thinking of my own experience at UC Davis, what strategies work to foster that communication that's required, the deep dives technically that challenge us to do new things and think differently? How does R&S and how have you kind of tackled that issue of bringing people closer together to solve the big problems?
Yeah, I mean, at first it helps when our design partners are equally invested in that messaging too. So, we've we've been successful just with presentations and explaining exactly those points below. We have a project with a client who asked, who took the initiative and asked us to say, hey, our board or our higher ups aren't necessarily going to understand why we're making this decision. We kind of get it at the project level. Do you mind doing a presentation and explaining to them what is going to be different about this facility compared to other facilities that we've had? And then we've kind of given the 30,000 foot view of things, and then they've asked us to do the same thing for their facilities and maintenance staff. And then we've had to get into more detail and explaining the type of equipment they're going to see, the type of things they can expect. So it's really just the communication aspect of it, but also having the engineering backup to really get into things and show the studies and show how, show them their load curves and show them how heat recovery and where heat recovery is going to fall into that load curve for them. Explain to them the benefit that they're getting from it in various seasons and what will happen, in the off season or in the peak, period. So they get a better understanding of the benefits of what you're trying to use for them, or, showing them how much money they were wasting using, natural gas and using, boilers and steam generation compared to what they have now. And explain that, yes, you're going to see a spike in energy, and yes, you're going to see increased utility costs, but you're not going to have the maintenance costs, and you're not going to have the utility costs of the other thing. So when what today might be net gain, cost wise, over the long run, you'll start to see things level out. So it's just having those the conversations and knowing your audience and what particular points they're going to want to hear, I think, is the best way to put it.
Right. And, the
Hopefully that
emergence
answered
of more big room approaches, and in California, especially the project delivery model of progressive design build really pulls a lot of efforts and conversations very early into the design process. And, because we're talking about a lot of programmatic issues, right? They're not things that can be layered on or try to be integrated later in design. We have to be starting with these things in mind.
Well, and there's the part of the question about, commissioning and what happens if things occur in different phases. Every project's unique. You do have to think of those questions. Do you have TES tanks that you can use during, use for your startup loads and that you can use during commissioning? Or are you going to have enough, heat load in the building to do what you need to do? How do you get across those? The earlier you have the conversations and start figuring that stuff out, the better.
Yeah. And Brian, you touched on costs a little bit, and I'll open it up to the floor. We're very focused on first costs in our industry, and as contractors, especially. Owners are interested in first costs as well, but there's also this idea of full life cycle costs and net present value, and thinking, making the best decision over the life of an asset. What kind of analysis or modeling have any of y'all done to think about that, in not just thinking about what we spend today to purchase something, but thinking longer term? How's that affecting your strategy, your process, and outcomes? It's the tough
ahead,
question,
Anna.
right? We're going to, on the record, talking about costs,
Yeah.
right? It's
Well, first off, I'm glad that people are thinking about operational costs.
certainly.
Because they'll add up over time. So we talked a little bit about the utility costs, that they're, generally speaking, for UCSF, this is going to increase our utility costs unless something unexpected happens with the natural gas market. Certainly it's been volatile in recent years. But there will be actually one project where we think the efficiency is going to increase so significantly by transitioning from sort of independent chiller, independent boiler systems to heat recovery chiller, that those costs are actually anticipated to go down. But for the most part, in comparison to cogen, it'll be a challenge and an increase in cost. In terms of the other operating costs, we've at this point only done really a superficial review, so I don't have a lot of detail, but I can say with confidence that it takes a lot of labor to keep a cogen plant running. And so I don't anticipate an increase in labor needs. I don't anticipate a decrease either. There may be a slight shift in function, but we actually did a bit of a labor analysis to see what it would what it would do, this energy transition, from a labor perspective. And the conclusion was not a significant change. But as I said, we'll get deeper into it as we go on. In terms of other maintenance costs, we have not yet done a detailed study.
I think for us, I mean, the one thing that definitely is going to increase is the amount of electrical equipment. So we've never maintained 21 kV electrical equipment on site. An additional step up transformer. So I think maybe from a labor perspective, kind of like Anna's saying, maybe we don't have that more people. I think we'll be more in the high voltage range and those types of things where we're going to have to add people. But there is just physically going to be more equipment that needs to be monitored and looked at as we expand. Now that could be regardless of electrification or just plain campus growth. But as we get bigger, we're going to need more people to do the things, to keep things going. But the big thing for us is definitely the electrical piece. I mean, we have something like 40 something 12 kV breakers currently, and we're expecting for that to double with this electrification push. The emergency diesel generators, you know, right now we have 5. We're going to get 3 in this current phase. We're projected to have another 8 altogether. And these are bigger engines and they're tier 4. So they're going to have SCRs on the back of them and diesel particulate filter. So some of this is an unknown. We don't know how intensive the maintenance is going to be on that particular equipment until we get it installed and we actually operate it and see what's going on. And storing urea in addition to liquid fuel and some of those things, just there's a lot of factors with a lot of this stuff that's new to us. And so trying to figure out exactly what those operational impacts are, we don't know. We just know they're there.
Thank you, Russell.
And I think it's going along with what Russell was saying too. It's not even just going 12 kV to 21. I mean, you may have a 480 volt facility that you all of a sudden decide you go to 4160 or 12 kV. And even that's a big jump in the medium voltage range for facilities, people that may not be familiar with it. And then the other thing, Jamie, is, you know, we mentioned the manufacturer challenges that we're having right now, the challenges with startup. Those don't just go away once you got it started up necessarily. So we might be experiencing some growing pains even beyond the warranty period with this equipment. And if we are going modular and we are doing, you know, seeing more pieces of equipment to achieve the same result, it's just, you know, it's just more opportunities for error, more opportunities for something to go wrong or for things that need just periodic maintenance. So I agree with Anna. There's probably just going to be a shift. There's just probably just going to be a shift of people who are used to working on one thing are just going to be moving their maintenance budgets to the other.
Right. Yeah. And we're getting close to time here, so I want to hand it back to Christina. I want to thank all of our panelists and all of you for the great questions, and we pretty much got to most of them, and I think it made our conversation better. So thank you for everyone being involved in today's presentation. Christina?
Yes, thank you all for the panelists and for the great questions and conversation. It was really illuminating. Please mark your calendars for the next Bending the Climate Curve learning event, which will be on October 15th at 8 a.m. Pacific, 11 Eastern, where we will explore reducing greenhouse gas emissions by converting from centrally distributed nitrous oxide delivery to point of use delivery. With that, we will adjourn. Thank you all. Have a wonderful day.